everyone. Welcome to this mathematical adventure. Today, we are going to explore a fascinating puzzle that involves complex numbers, square roots, and a surprising result. The expression we are going to solve is the square root of 1 plus the square root of negative 3 plus the square root of 1 minus the square root of negative 4. At first glance, this looks like a messy complex number expression. But as we will discover, the answer is actually a beautiful, simple real number. Let's to solve it. The Fraudner statement here. Oh, central question. What is the value of this expression? It looks complicated, doesn't it? We have a square root of negative numbers, which means we are dealing with complex numbers. The big question is the answer real or complex? Our intuition may say it's complex because we are working with the imaginary unit odd, but the answer may surprise you. Here, we are going to find the value of x here and square root of 1 plus square root of negative 3 plus square root of 1 minus square root of negative 3. Is the answer real or complex? Despite having negative square root, the final answer may be surprising you. Let's convert square root of minus 3 to complex form. Square root of minus 3 equal to square root of 3 multiply square root of minus 1 equals to square root of 3 odd. After substitute into original expression, we have square root of 1 plus square root of 3i plus square root of 1 minus square root of 3i. Note the expression is complete in complex form. We use polar form of complex numbers. For 1 plus square root of 3i, we write on equals to square root of 1 to the 2 plus square root of 3 to the 2 equals to square root of 4 equals to 2. And that equals to add tangent square root of 3 all at 1 equals to pi all at 3. So 1 plus square root of 3i equals to 2 e to the I pi over 3. And also for 1 minus square root of 3i, r equals to 2 and theta equals to minus pi over 3. So we can write 1 minus square root of 3i equals to 2 to the e with 2 multiply e to the minus I pi over 3. So, a square root in complex number, the general formula, we have the square root of r e to the I theta equals to square root of r multiply e to the I theta over 2. Apply the above formula to the expression. So we have a square root of 1 plus the square root of 3i equals to a square root of 2 multiply e to the I pi over 6. And 1 minus square root of 1 minus square root of 3i equals to a square root of 2 multiply e to the I pi over 6. And this sum of the expression equal to square root of 2 multiply e to the I pi over 6 plus e to the I minus I pi over 6. We use the other identity e to the I theta plus e to the minus I theta equals to 2 cosine of theta. So after applying the identity, we have e to the I pi over 6 plus e to the minus I pi over 6 equals to 2 cosine of pi over 6. And calculate the cosine of pi over 6 equals to the square root of 3 over 2. So 2 2 cosine of pi over 6 equal to 2 multiply the square root of 3 over 2 equals to square root of 3. So the result is square root of 1 plus square root of 3i plus square root of 1 minus 0 square root of 3i equals to square root of 2 multiply square root of 3 equals to square root of 6. And final answer is surprising you. The answer is the square root of 1 plus square root of minus 3 plus square root of 1 minus square root of minus 3 equals to square root of 6. This version contains complex numbers, but the final answer is a real number. We know that the square root of 6 approximately equals to 2.449489743. Why is this surprising? Combining complex numbers can lead to this a simple real answer. This is one of the beauties of the mathematics. Also, we can have the geometric representation for the numbers in complex plane. We have a circle of a radius of 2, and then you can see the 1 plus square root of 3i in the upper side of the circle, and 1 minus square root of 3i in the lower side of the circle. So the angle of theta is equal to plus or minus 60 degrees. So here we have the summary of resolve. The problem is square root of 1 plus square root of minus 3 plus square root of 1 minus square root of minus 3. And the final answer is the square root of 6. Here the solution is sketch. We assume that the square root of minus 3 is equal to square root of 3i. And all the convert to polar form 1 plus minus square root of 3i equals to 2 multiply e to the plus minus I pi over 3. Calculate a square root. Although is equal to a square root of 2 multiply e plus minus I pi over 6. And we use the Euler identity. E to the I theta plus e to the minus I theta equals to 2 cosine of theta. So after the multiplication of square root of 2 multiply square root of 3 equals to square root of 6, and final answer is square root of 6. Thank you for watching. See you next video.